You are sitting in a coffee shop. You finish a document and hit send. Instantly, your file is off to a coworker across town. But beneath that simple click is a complex technical operation that must bridge the gap between two separate addressing systems before a single byte can leave your device. Online communication relies on two different addresses. First is the IP address, your temporary digital location. When you move from your home Wi-Fi to a coffee shop, your IP address changes to reflect your new spot on the network map. This slide compares these addresses. At the bottom, IP addresses operate at layer 3, navigating the broader internetwork. At the top, the MAC address operates at layer 2, a permanent 48-bit physical fingerprint burned into your network card for local point-to-point delivery. Here is the functional hurdle. For your file to actually exit your laptop, the network packet containing it must be wrapped inside a physical container called an Ethernet frame. To transmit that frame, your hardware requires the specific physical MAC address of the device it is being handed to. This creates a disconnect. Your computer knows the IP address, but it does not yet know which physical NIC on the local network should receive the data. Let's look at how your computer resolves this, starting with a direct delivery. Imagine you are back at the office, sending a file to a coworker sitting a few desks over on the exact same local network. Your computer knows their IP address, but not their MAC address. It first checks its internal directory, called an ARP table, to see if it already has your coworker's physical address on file. In this case, the table is empty. To find that missing piece of information, your computer uses the Address Resolution Protocol, or ARP. Your device sends an ARP request, an Ethernet broadcast shouting, "Whoever has this IP address, send me your MAC address." Every device in the single broadcast domain hears it, but only the computer holding that IP accepts the message and sends an ARP reply. Your computer receives the reply, stores it in the ARP table, builds the Ethernet frame, and initiates direct file delivery. For local communication, ARP acts as an on-demand network directory. It bridges your logical intention to send data with the physical reality of the local hardware. Now, what happens when you want to send that file to a client in another country? This requires indirect delivery. You might wonder why your computer doesn't just use ARP to broadcast out to the entire internet to find the client's MAC address. If every device on Earth broadcasted every request globally, the volume of traffic would overwhelm and crash the entire system. Notice the central router in this diagram. It acts as a boundary, connecting networks while blocking broadcast traffic to create manageable domains like production and sales. To reach a remote client, your computer cannot deliver directly. It hands the packet to this default gateway. The computer adapts the ARP process. Instead of asking for the distant client's MAC address, it sends a local ARP broadcast just to find the physical MAC address of the local router interface. The router accepts the local frame, strips away the MAC data, reads the destination IP address, and forwards it to the internet. By containing ARP broadcasts strictly within local domains, the internet can scale without collapsing under the weight of its own communication requests. Network communication relies on a precise handoff. Modern applications use logical IP addresses to route your data across the globe, but the network hardware relies exclusively on MAC addresses to move that data locally from one node to the next. Protocols like ARP for IPv4 or Neighbor Discovery for IPv6 serve as the constant translators between these two worlds. They map the digital location to the physical hardware. Without this translation layer, your data might know its final destination on the other side of the planet, but it would be trapped right here, unable to take the very first physical step out of your machine. While your IP address changes with every new Wi-Fi connection, your permanent MAC address, located and mapped through the work of ARP, is what allows your hardware to actually receive the web pages coming from the cloud.